the easiest way to do them as I see it. So the first part, remember, was kind of a rectangular, a square, I guess, cylinder that was 3 inches long and had a hole in it that didn't go all the way through. So the way I would do that, so I'm going to do this as an extrude to make the square cylinder. And so I started a sketch. I'll make a square, and we want this to be 1 inch by 1 inch. So now that I have a square, I'll go to the dimensions. I want that to be 1 inch. I want this one to be 1 inch. So there's the square I want. And now I want this cylinder to be 3 inches long. So I'll highlight the sketch I just did and go to extrude. And I want this distance to be 3 inches. I don't know if that did it. Yeah, 3 inches. Now here's the written part of the test. Yeah. And now all I have left is just to cut the hole out of it. So I'm going to go to sketch again, and I'm going to cut the hole out of this square here. So click on that, and then I want my hole to have a diameter of 0.8. So that's the right size of that circle. And now I want to extrude this out. So I'll go to extrude. I want it to go this way and remove material. And I just pulled it straight to 2.5. That's how far we wanted it extruded. So there's the shape. And then for the second one, remember this was the kind of the bowl with the slanted out sides. This is by far easiest if you recognize that there's an axis of symmetry. So you have this shape that's like this. Okay, so if you recognize that there's an axis of symmetry that goes straight through here, then you know that you can just make the profile of the side and then do a revolve around that axis. And then it's pretty quick if you recognize that. So again, I'm going to start with a sketch. And I'm going to use a line tool. And so my profile goes like this. Okay, and now if you can picture the axis I'm going to revolve it around is this. So I'm just going to take this shape and swing it around. So first I want to get the dimensions right. We have, so let's see. This was a funny length, I think. And remember that when you revolve it, like this is going to be 1 radius. This is going to be 1 radius. So I gave those dimensions as diameters. So you want to do half of those diameters. So the one at the bottom, if I remember right, was like 3.62 or something. And so we'll make that half of that, which is 1.8 1.81, I think. And we want this distance to be 3.5 because the diameter was 7. And we want this distance to be 2.5. And then we want this wall thickness to be, where's my dimension? We want this wall thickness to be 0.5. And we want this wall thickness to be 0.5. Okay. So that's a complete sketch with the dimensions all done. And now all I have left is to revolve this shape around the right axis. So I'm going to highlight that, go to revolve. It asks what axis I want to revolve it around, this one. And so that's the shape. Any questions about either of those? Yeah.
You said you posted the our feedback for the report.
Yeah.
Find it.
Okay.
Yeah.
Okay, let's see. Well, let me disconnect this for a second, just so I'm not showing everyone's grades on the screen. Okay, so if you go to, go to assessments grades, disconnect it again. And then I think it probably just shows a list of, so I think it just shows like your,
So in the grades tab, I can only see the class average. There's nothing in the actual. There's all the weekly assignments and such and quizzes, but there's nothing. There's only the class average.
oh, weird. I wonder what happened there. Okay, I'll fix that. Thank you. All right. And then also there's feedback for your CAD design projects that we're going to 3D print. So look on D2L for feedback on your Fusion, CAD product. So we're going to start getting those 3D printed. I want to do one more iteration of looking at, suggestions, thinking about improvements and stuff like that. And then for the people where I think they're pretty well thought out and ready to go, we'll start printing those out. So there's going to be an assignment related to that I give you this week. Okay, so look for that on D2L. Okay, so now we're going back to electric circuits. And let's start by just doing a quick calculation before we get into the new stuff. This is a review So let's say that we have a 6-volt battery and a resistor. Let's say we have a resistance of 500 ohms. And we want to know what's the voltage across the resistor and the current through the resistor. Well, the battery and the resistor are in series. Okay, electricity has to go through one and then through the other one, which means that the current is the same in both of them. Okay. So let's go. All right, so I'm going to write this again here. We know that the long side of the battery symbol is the positive side. So that's going to be a higher electric potential than the short one. And so we know that the positive is over here, the negative is over here, and the difference in electric potential there is 6 volts. Okay. We also know that for these parts that are wires, the electric potential has to be the same. So if there's a 6-volt difference across this battery here, this has the same potential as this. This has the same potential as this. So there has to be a 6-volt difference in electric potential there. Okay. Now we're going to figure out the current. So Ohm's law says the voltage is equal to the current times the resistance. So 6 is equal to 500 I. And so the current is 0.012 amps. Or if you want to think of it in milliamps, that is 12 milliamps. And then the direction of the current is going to go, it's going to go from the positive of the battery towards the negative of the battery. So it's going to go, and it can't go like through the battery. It has to go around the circuit. So it's going to go this way, which means that the current up here is this direction. So for the resistor, the current is this way at, 12 milliamps. Okay. Since they're in series, you also know that that's the current being drawn from the battery here, and it's going this way at 12 milliamps. Okay. So that's solving a simple circuit with one voltage source and one resistor. Anybody have any questions about that? Let's do one. Let me give a... So let's say that we have the battery over here, a resistor there, and let's say that this is 12 volts and 350 ohms. And we want to solve this circuit, which means find the voltage with the polarity. That's like the direction of the voltage, which one is positive and which is negative. And the current with direction for each element. Okay, so we know that this electric potential is 12 higher than this. So that means this is 12 higher than this. So that's sort of the first step, is figuring out the voltage across that resistor. So we're given over here that this is 12 volts. And that means that this is 12 volts with this polarity. Anybody confused, have any questions about why the voltage is that way on the resistor? Okay. And now we know that the current is going to go from the battery. It's going to go from the positive side around the circuit toward the negative side. So it's going to be going around like this. So we already know the directions just from like sort of inspection. Now we can go to Ohm's law to figure out the value of that current. So Ohm's law says that at the resistor, 12 is equal to 350 I. So the current is 0.034 amps, and that is 34 milliamps. And so for the current, the polarity is this direction. Not the polarity, the direction is the direction shown, and the magnitude is 34 milliamps. And the same with this one, 34 milliamps, because they're in series. Okay? So we're not going to have to do like very complicated circuits. Really, resistors to us, when we're doing robotics and programming and stuff, resistors are just going to be tools to control the voltage and or the current going to devices. Okay, so our circuits are going to be simple like this. Now the next thing we're going to talk about is multimeters. So, the most important tool that we're going to have while we're working on circuits is to be able to actually measure voltages and currents in a circuit that electricity is running through. Okay. So we're going to talk about multimeters. And we're going to use these to measure voltage. Let me put it in a different order, actually. Resistance of a resistor. Voltage and current. So we're going to spend some time making circuits, doing calculations to try to figure out what the currents and voltages are going to be on the circuits, and then we're going to actually measure them with the multimeters and see that they match. one thing is if we're just doing simple circuits like this, it might be a little unclear why it matters to us to be able to measure resistance in a resistor or measure voltage, since the voltage is just going to be, in most cases, in the simplest cases, the same as the voltage of the battery. Well, batteries say the voltage on them, and resistors say the resistance on them. Why would we ever want to measure those? I guess one is to see if there's a malfunction. Yeah.
There's like a percent difference.
Yes, exactly. So those gold and silver lines on the resistors, remember, tell you the percentage error. And so they'll give you like a ballpark. But if you're trying to do any careful calculations, you want to take those measurements to make sure. And it's the same thing with a battery. So a 9-volt battery just means that that voltage is in the ballpark of 9 volts. We'll also see some sort of funny behavior with batteries that you have to take into account. Once you start drawing currents out of batteries, the voltage will change. Okay, so that's why we want to be able to measure these things. Okay. So the first thing I want to say is, so we're measuring these 3 things. I want to just start by let's have a sort of a attitude of, I don't want you to think like, let's see what happens. Like, I'm not sure what'll happen, but let's turn it this way, plug it in here, let's see what happens. You blow out a lot of fuses if you do it like that. Okay, so let's just try to approach this carefully, cautiously, try to save fuses, blow as few fuses as possible. The one thing I want you to notice is that current measurements are the easiest ones to blow fuses on. So be extra careful when you're measuring current. And then the second thing I want you to get in the habit of doing is, after every measurement, turn the dial back to the off position. Okay, there's 2 off positions, the top and the bottom. You see that? So right now, turn your dial to between measurements, turn to the off position. Okay, the first thing we're going to measure is resistance, and that's the easiest one to measure. Did I get 2 cords? Maybe not. I had you get 1 red and 1 black. By the way, there's no difference in how these function. They're just wires. But having a red and a black can often help you sort of organize your thoughts on how things work. The red is always used to go to the positive electric potential and the black to the negative electric potential. Okay, so it's a way to sort of visually organize things. So we're going to start by measuring resistance. And notice that at the bottom you have these 3 jacks. And they say amps, milliamps, COM for common, and then V omega. Okay. This is always going to be the black lead. So you never have to take it out of there. This is always going to be our negative, okay, or our ground. And then these other ones are telling you where you put the red lead. If you're measuring current, you'll put the red lead in one of these depending on how big the current is. Usually for us, it's going to be this one. Okay, but if you're trying to measure a really big current, then it'll be over here. We'll talk about that more later. If you're measuring voltage or resistance, that's a volts and an ohms symbol, then the red is going to go over here. Okay. So and let's start by let's get out the 330 ohm resistor out of the kit. So remember on that, using that code over there, the one I gave you last time, that's going to be orange, orange, brown. And plug the black lead into the common and the red lead into the voltage and resistance. So, you know, it's going to look like that. And now the last thing we have to do to take this measurement is it gives us, notice on the dial, there's one quadrant has all of the resistance measurements. So here's the dial, and down here is the resistance. And it says 20 mega, 2 mega, 200,000, 20,000, 200. Okay, and you always want to choose, you want to put the dial on the smallest value that's bigger than the resistance you're expecting, okay? So you're going to turn the dial to the smallest resistance that's bigger than the R you expect. This isn't something you have to worry about with the fuses or anything. This is just a significant figures thing. So if you are measuring a 330 ohm resistor and you have it set on 20K, you know, it's not gonna give you very many significant figures in your calculation. It's just not gonna have a lot of precision. So we wanna go to, well, we have to go to, I didn't write the 2K. So we wanna go to the 2K. So move the dial over to the 2K. And it says overload until you touch it to the 2 terminals of the resistor. And now touch the red to one terminal of the resistor and the black to the other. And mine says 0.325. That's given in kiloohms, so that means 325 ohms. Okay, let me draw a picture of this. So we have the dial set to 2K. And the resistor is here. And we're going to take the black and touch it to one side. It doesn't matter which. We're going to take the red and touch it to the other side. And up here, it'll give you the value. Is everyone getting that to work? So take a note of what it says that resistance is. That's the resistor you have here. Okay, so I have this one that's 325 ohms. Let's measure 3 more of these that we're going to use in these calculations. Let's do a 10,000. So the 10,000 is brown, black, orange. And measure that the same way. No, okay, so right, so this time you're always going to the smallest value that's bigger than what you expect. So we have to go to 20K on this one.
Yeah, the first one was 2% off. It's also rated 5%, 4.5 from the first one. Still is that.
And then let's do it for the 1,000. So that's going to be brown, black, red.
What color is this one?
The 1,000?
Yeah.
Brown, black, red. What? The 1,000 you can go to 2K. So it's always, basically it's always the smallest one that doesn't say overload when you do it, you know?
So everything after you recorded, you times it with 1,000.
All the ones that say K on them. So if you have it on the 200, then that'll just be ohms. That'll be regular ohms. But all of the settings that say, so this one, let's see, the two that have M's after them, you would multiply by 1,000,000. The two that have K after them, the three that have K after them, you'd multiply by 1,000. And then the one that doesn't have anything after it is just in ohms.
So even 2 and 20K each is multiply with 1,000.
1,000, yep. So the multiplier is just the letter after it, the K or the M. How's this going? Everyone getting all these? And then I have a set here. I want to do one more. So these are only 10 ohms. These are really small resistances. So measure those also. I'm giving you these. I want to collect these separately at the end so they don't get mixed in with those boxes. But yes, exactly. So for the 10 ohm, you'll put it on the 200 ohm setting.
Oh yeah.
Yeah.
There's like a smaller degree in the ohm thing. Are you sure I want to use that instead? It doesn't have a number on it. Or is it?
Oh, that's that's a continuity thing. That's a different thing. That's a way to check if your circuit is blown or something. Did I give you all anybody waiting for the 10 ohm resistor?
We need a different one. This one's only 9.9.
That'll work for our purposes. Just keep trying them until you get exactly 10.
Yeah, you shorted us.
That's like electricity humor. And get in the habit of setting between your measurements, get in the habit of setting it to off. Okay, setting the dial to off. Oh wow, mine's big. Mine's 13.8 point.
Seems out of spec.
It does. 13.2. 15? Wow. That's funny. For this one, we're going to do the same thing. So you have the amps, the milliamps, the common, and the voltage and resistance. And like every measurement, we're going to have the black lead into the common. And it says that this does voltage and resistance, so we're going to put the red lead into voltage and resistance. And this time the the dial is going to be turned over towards the upper, wait a sec, so we're measuring direct current, not alternating current. So that little switch is going to be on direct current. If you see that, let me draw this. So we want it to be over here on direct current. And the values that are given are 1,000 volts. We're never going to get that high. 200 volts, 20 volts, 2 volts, and then 200 millivolts. And the same way that it worked with the resistance, if you have a unit prefix, like there's only one of these that has a unit prefix, the 200 millivolts, that means that you'd have to multiply what it gives you by 1,000 to put it into volts. Okay. And so we're going to start by taking the 9-volt battery. And so we have our 9-volt battery. We have the positive and the negative. And we're first going to do this measurement with no current. So take your battery. And just go directly, I guess I'll draw it. So the positive is going to go to the positive terminal of the battery. And the common ground is going to go to the negative terminal. Okay. And like always with these, we want the dial set to the smallest number that's bigger than the voltage we expect. So what would that be in this case? 20, right? And mine says 9.59 volts. Any questions about that? Is everyone still following along on these things? Okay, so now we're going to put together a circuit. We're going to draw a little bit of current out of the battery and measure the same thing again, okay? And we're going to do it 3 times with 3 different currents being drawn out of the battery. We're going to start with the smallest amount of current being drawn out. Of all of these resistors, so if we're going to make a simple circuit with a battery and a resistor, would we want the smallest resistance or the biggest resistance to make a small current? Biggest, that's right. So we're going to start with the 10,000 ohm resistor. Um, and so we're going to set up our, our battery. And the way we're going to do this is with a breadboard. So remember the way it works is anything that you have in one of these columns on the edges, it's like you're connecting those 2 points together. And the same thing if you put any 2 wires in these horizontal rows, it's like connecting those 2 wires. So we have our 9-volt battery here, the positive and the negative. I'm going to go from the positive to here, say. And then I'm going to go with my breadboard. I guess I'll go wire this to this. And then I'll put the resistor in here. And then I'll connect this to the negative. Does it make sense why that would make this circuit, close this circuit and let electricity flow? So right now we don't have the multimeter in this at all. We're just making this circuit. Feel free to come look at mine if you get confused. So now what we're going to do is we're going to take the multimeter and we expect the voltage to be about what it was before. So I'm going to put this on 20 volts. And we have the black wire, the black lead will touch that to the negative terminal of the battery. And the red lead will touch to the positive terminal of the battery. And if we have this set up right, we're going to measure a voltage that's very close to what we got when there was no circuit. Okay? So try that and see what you get. And for this one, I got a voltage of 9.58. Pretty much the same. Oh, I had 9.59 before. Basically the same. And what did you get for voltage this time? Lower, yeah. I got 9.45 volts. So it's still in the same ballpark, but as you draw more current from a battery, its ability to, as you draw more current from the battery, its ability to produce voltage goes down. By the way, what would you guess would happen if you, so we've been touching the red lead, the positive lead to the positive terminal of the battery and the black to the negative terminal of the battery. What do you think would happen if you switched those?
It would be a negative voltage.
Yep, exactly. It would give you the same voltage, but it would be negative. Basically, the multimeter is just taking the the red electric potential minus the black electric potential. So if you switch, you just get a negative number. Okay. So basically, you can think of a negative number as showing you guessed wrong about the polarity, or later you guessed wrong about the direction of the current. Okay. So now let's do the same thing one more time, but use the 10 ohm resistor. So this time, there's going to be a much bigger current running through the circuit. And so we would expect the current to be a lot less.
Did you just get the 100 burn up for you?
No, it got really hot though.
Yeah.
Smell it? You can smell it when it's getting hot like that.
Oh, yeah.
Okay, well, I got 9.25 volts here.
I got 912.
9?
9.12.
Okay. Yeah, so anyways, I didn't do this to try to make these smell funny. I did this just to show that as the current goes up, the ability of the battery to produce voltage goes down. So like one thing, you know, like a car battery you see this giant car battery and it's only 24 volts, right? Chase, 24 volts? Car battery, 24 volts? Oh, 12 volts. Okay, so it's very low voltage. You know, I mean, you think like, oh, maybe that's like 1,000 volts. It's so big or whatever. 12 volts. But so you're like, well, I can make an 18-volt battery by just hooking up two 9-volt batteries in series, put the positive of one to the negative of the other one. That's a battery that has 18 volts, more voltage than a car battery. But it can't start your car. And what a car battery, the reason it's so big, what it's able to do is pump out a really high current without the voltage dropping. Okay, so a 9-volt battery like this, if you start asking it for a lot of current, the voltage is going to drop really quickly. And if we had resistors that could handle more current, we could go lower and lower with the resistance. But I guess I should have looked at the specs of those resistors before we plugged those in. But anybody have any questions about how that works? So that's something that, like, when we start doing the robotic stuff, you're going to have to consider sometimes is like, okay, this battery has 6 volts or whatever, but that doesn't mean it's going to have 6 volts once you start using it to power a big motor or something like that. Okay. And so, so it's often worth it to measure the voltage of your battery in the setting that you're giving it. Okay. All right, so as you draw more current from a battery, the voltage drops. And that's called internal resistance, is the name of that phenomenon. So now we are going to measure the current. And I just want you to get in the habit of saying, okay, we're measuring the current now. You just need to be careful about how you're setting up the circuit to do the measurement. This is the one where it's easy to blow fuses. And so what I want you to notice is when we measured voltage, we made the circuit. And then we used the multimeter. You can think of it as the multimeter was just an observer of a circuit that was working the same whether the multimeter was plugged in or not, okay? So then we touched terminals with the multimeter leads. To measure current, we're going to do something differently. To measure the current, we have to break the circuit and insert the multimeter into the break. So in this case, the multimeter isn't observing the circuit, it's part of the circuit, okay? Okay, so let's go back to a bigger resistor. So I guess we're definitely done with some of those 10s. And we're done using even the ones that still work. And so this time we're going to do something like this. I'm just copying this. Well, okay, so we have our battery. And we have our breadboard. And I'm going to go from the positive of the battery, I'm going to go I'll go here. And then I'm going to insert the multimeter. So so now I'm going to go from here into the milliamps of the multimeter. And then I'm going to go into the breadboard. And then now we can go to the 10,000 ohm resistor. And then we can go back to the battery. Okay, so notice that the way this is set up, electricity current goes from the positive terminal of the battery to here. And now if this multimeter was not in this setup, no electricity would flow at all. Okay, that's what we need when we measure current. You see that? We'd have current that would try to go here, but then it would have nowhere else to go. But we've put the multimeter in, so it goes here, goes through the multimeter, and then continues with the circuit. Okay? If you don't do that, if you have a current where electricity flows, even without the multimeter, and then you touch the multimeter leads to points on that circuit, that's when fuses blow. Okay, so you can't do it the same way you did it with voltage. It has to be, and one way you can do it always is make the circuit, then choose two spots where you break the circuit apart, actually separate one that you've already had working, and then connect the multimeter there. that's always an approach that works. Okay? So this time, let's do this calculation. And then we're going to do the measurement of the current and see how it compares. So this circuit, here's what it looks like. We have a 9-volt battery. Not 9, I'm going to actually use the voltage that we measured. So what did I measure for the voltage when we had the 10,000 ohm resistor? The 10,000 ohm resistor was 9960 for me. Use the one that you got. And with that resistor, the voltage was 9.58. And so that means that this is going to be 9.58 volts. And so now we can use Ohm's law to calculate what we expect the current to be. And so Ohm's law says 9.58 is equal to 9960 times the current. And so the current we expect is 9.618 times 10 to the minus 4 amps. Or in other words, 0.962 milliamps. Okay, so now what we're going to do is make this circuit and measure it. You really could just do this. You could skip this whole thing and just go straight from here to the multimeter. No, so this time we're going to go to milliamps. So we're going to have the black lead in the common like always, and the red is going to be in the milliamps. And then when it's time to turn the dial, we're going to use the 2 milliamps button there. It says 2 milli over 2 amps. So that, the one on the top is if you're plugged into the milliamps jack, then that has a max of 2 milliamps. Okay, so I'm going to go positive. And this is, when you're switching the jacks around, that's when you really need to have the multimeter off. So that's why it's a good habit to always turn it off before you, like right after you finish a measurement.
Well, not yet. When you set it to amps, when it was asking for wires, so it's actually all perfect. So it has to go through.
What happens if the meter has a blown fuse? Does it just read 0?
I can't remember. That seems likely though. Does it?
You're not getting anything.
Okay, this one works.
What was this there was they do?
10,000? Here you go. Look at that one.
Yeah, so here.
Here, let's just. Oh, here's your amps. So let me look at it. So you have the there.
The potential.
Yep. And okay.
Yep, that one has a bad fuse.
Okay. Yeah, it happens so often. It's not like they're hard to replace, but
Oh no, just pop them off. And are they the little
Yeah.
glass ones?
Uh-huh.
Yeah.
I think the ours, I'm not sure.
okay.
This is when it just goes in the closet.
Yeah.
Yeah. Okay.
What is it?
Oh, there we go. 892. What?
Scroll up so we can see.
Yeah.